Starting up.
You're on.
Yeah. What I've got here is just unfolding a story about what we've just covered. Really about qualitative mapping. So to start the modelling process, we need to be clear about the purpose of the model, and also to ask a research question or a focus question that is quite specific. A carefully placed stake in the ground, as Barry Richmond used to put it. You may not put it in the right place, but you put it carefully so you can, again, this idea is that you'll know when you're wrong rather than keeping it fuzzy. Now, I guess the issue is that what we're trying to do is have a group of stakeholders who all see the world a different way. And so that's really what we're trying to capture, those different views and integrate that into a single piece of logic. So we need to think about, for each group of stakeholders, their key outcomes and interventions, given the purpose of the model. And for each view of a stakeholder, there may be different time frames of interest. For instance, strategic, tactical, or operational, some years, some months, some hours or minutes. And those involved and those affected need to be really part of the process. But after that, I guess one of the things is, let's decide on the key time frame of interest. You're really interested in how many years, what sort of level of fine-grainedness, is it days, hours, months, years? And this comes in later on when we have to choose the time units of a model.
Time units and time horizon.
Yeah. So again, keeping things simple is good to get started. And the other thing is that we basically, a lot of our modelling more recently is looking at interventions. Which interventions do we want to test in the model? So that often gives you a good thing to focus on. People are fairly concrete about what they know. They've designed an intervention. Somebody's probably got a pet intervention they've spent years trying to hone and try and get it accepted or rolled out. So the interventions are a pretty good way to get people to crisply think about what they want to do. It's sort of shortcutting things a bit. The other thing we find that most people start out doing a process mapping because that's what they're used to, a flow chart, and they often do that. It may not be the best place to start, but it's generally where people are most familiar with. I think, and others do, that you're probably better to teach people systems mapping first before they learn process mapping. I find if they learn process mapping first, it's actually quite hard to shift them into other ways of mapping. That's just, yeah. So again, but whatever suits them, again, the idea is to, whatever's in the heads of these stakeholders, they need to get it down on paper. There are two reasons to do it, so they can share it and improve it and integrate all these views. But another good reason is that sometimes it's just a brain dump. You know, you've got to build a simple model. People have got all sorts of ideas. They put it all down, and it's a lifetime or many lifetimes' work. So getting it out of people's head and on paper and on the concept map is a good way to basically get it out of their heads, and then you can decide, again, which 90% to leave out. And everyone feels comfortable, at least they've put their pet bit down somewhere and it's there and you can document it, even if you never get round to adding it into your next stage computational model. So then we go to the mapping of really causal pathways. What sort of, again, just general population factors that interact and looking at feedback loops. You may or may not want to identify stocks at this stage. It really doesn't much matter. And again, I come from the Barry Richmond, Mark Heffernan school where I like a stock flow causal loop diagram rather than just a causal loop diagram. It shows you a piece of structure that I think it's easier to understand, particularly when you start putting outflows in as loop. It's just sort of clutter that doesn't help. Just having an outflow from a stock is much better than having a little feedback. Little feedbacks that really are just clutter. So again, this is a good example that Tom Fitterman has, where how do you combine two stories? One person's talking about, why did the chicken cross the road, and the other one's talking about, well, what came first, the chicken or the egg? So here's a nice way to combine those two stories into something that even a computer can understand. Now, I've got this in a PDF, so you can look. There's a link that you can go to. And there's a little story. There's a sort of story comment message down the bottom, but you can't see it because of the screen resolution. So again, we're questioning the boundary of analysis to make sure we include the wide range of causal influences. So again, George Richard often says that, yes, SD is really looking at the endogenous view. So again, this is certainly the story of my life that, this year's nightmare is usually last year's great idea coming back to bite me. So again, the agent, a thing or an object that acts. That's all an agent is. And other people call it an actor. And it's often a person. And it can have properties and methods. If you're into object-oriented, it's a method, or you can call it generally an action. And basically, actions change their own properties or the properties of others. And they're generally, they can change based on outside or inside factors. Now, a state is kind of an idea. If people aren't used to it, we often basically say, well, let's think of coloured dots on a map. That's a little thing over there. And say, well, what would make you want to show a changing colour of a person moving on a map or on a map? What sort of colours would you have? And they're the states that people can understand. So they're the discrete states of interest, the key ones. Now, of course, we said there are could be many state charts. The other thing we find sometimes interesting is really look at a decision. There's a decision explicitly link and connect decisions. And it's really, these decisions are made according to rules, so that introduces the idea of rules about decisions. And of course, you can combine all of those into a more complex state chart, which we'll see. Again, remember, you can have a continuous variable inside an agent or outside. It doesn't really matter. So stock to me in this sort of mapping is just, well, you know it's going to be a continuous variable, something that's going to move up and down like water, rather than coloured dots moving across the map. And again, the feedback loops inside a person might be something like emotion regulation, which is certainly important in a lot of behavioural models. So then once we've got one agent, we can add another, say, drag in another little figure and say, well, now we're interested in a network. What are networks and connections with agents? What are the interactions agents are having with other agents? And the key one we like to think of in healthcare, particularly in the sort of broader level healthcare, is the reaction between the patient, the formal and the informal carer, certainly for most chronic diseases. And then, of course, you can build up a whole network of connections. You can locate them either via group relationships or by spatial locations. And again, we're often interested in whether agents move or whether we're interested in them moving. Are we interested in them while they're moving, or are we interested in them just that they have moved, so their final state? And then there's a whole lot of stuff about, you've got to think about resolving classifications and thinking about whether some things are nested, so you can have these sort of boxes within boxes or nested Russian dolls in some of your diagrams if you want to get fancy, to look at some sort of hierarchy. And a lot of the stuff we find, there are a lot of people pushing design thinking, linking, well, how do you actually link this to a lot of the design thinking literature? And now you can go off and build your own, roll your own maps, basically. But that's, again, just a thing. As I say, you can click on, we've uploaded a PDF that you can click on the link and play through, and maybe it'll show up a little bit better on your screen. There was one other slide, but that's probably enough.
Oh, the slide you gave me?
Yeah, it's all right. We've got two other slides about what I've got is what makes a successful group model building. What sort of group do you really want to work hard with, and which groups are you just really having a practice to make sure when you get a good opportunity to make a difference, then that might work. But I think the PDF should be up there somewhere.
Yeah, it's under here. This one here, right?
Yeah, just the PDF. Yeah,
okay.
That's the one.
Did you want to show? Okay, you want me to just give it to them?
No,
okay.
you just put it up there.
Very good.
We're running out
I'll do
of
that
time.
right now. So I'll put it up on the site here. Thank you, Geoff. And let me just go upload it. Okay, so this will be under lecture slides. And here we go. Boom. Okay, and we want to do here the boot camp. Boom. Lecture slides. Boom. Guest lectures. There's the McDonnell. Okay, and so Geoff's is now uploaded, and I'm going to further upload this introduction I gave to system science, and maybe we'll just see if there's yeah, I'll do the others in just a bit. Okay, great. So based on Geoff's Geoff's comments there, hoping you're having some additional appreciation for how we might use a tool such as the one that I was showing earlier, the CQHM tool. The question came up, which I thought was a very good question, of how does one secure access to this after the fact? So, okay, so we created this and we shared it, and now others such as Wade can access it. I could share it with other people in the room as well. How do we go access that? Well, my comment on that is that we could actually go and look at my Google Drive, and my Google Drive is going to include now a file with this name that I created in CQHM, and I think it was called Bootcamp Model 1. And so yours should have the same feature. If you created it with a certain name within your Google Drive, you should have that listed. So I'll see if I can get it listed here. Let's go do last modified, and we should be able to find it on the drive here. Here we go. And okay, I have a considerable volume of material. Bootcamp Model 1. Here it is. And I believe we can do open with here, and I think we can even just click on it, and it will open it up here for editing. Okay? So in short, it's saved on Google Drive, and by double-clicking on it, we can open it up. And I appreciate Geoff's vote of confidence. Hao also mentioned to me that we can zoom in and out here, which can be quite nice for kind of putting larger structures in place, or going in and modifying things at a more detailed level. Okay, so thanks to Hao for spotting that. Okay, so we provided you some general words of suggestion on model conceptualization, the need to start simple, delineate exogenous, endogenous, ignored portions of your model, articulate in the form of a model map hypotheses for sort of causal pathways, and that can be done through a tool like this or more informally on a board. And this will be a key step towards getting your model into any logic starting tomorrow. Okay? So I would encourage the project teams to undertake that right now, okay? To give this a try with a TA Circulate. I'm going to post the PDFs from earlier today. I'll take a look, if I can, at a few people's, and then I will announce a Java tutorial that I'll be running as well. And some people may want to attend that. It'll be in another room called S386, which is down the hall just to the left, just past the washrooms and to the left. I will announce when I'm going to do that, and anyone who's interested could join. Today we'll just give a very high-level introduction. What is this Java thing, and how does it fit into any logic? Subsequent days we'll go into more detail about features of Java, including things like statements, which are sort of commands to it, formulas called expressions, and how we can use it to create functions and basically accomplish useful things in our models. Some data structures in it, etc. None of that is mandatory, but if anyone is interested in kind of getting a little bit more into any logic and building up models from scratch on your own, that might be a good thing to take in. First, I've got to do some work here, getting you some slides, etc. So I'll be attending to that, take a look a little bit how things are going, and then announcing that. TAs, could you summon the TAs? Now is the TA's time to shine. Okay? Okay. So thanks. Any questions? Yeah.
So approximately when will you be done? Like half an hour, an hour?
I think it'll probably be in about half an hour. Yeah. I'm going to double check the schedule and see how things are done, but my best guess would be in about half an hour. Yeah. Okay? And it'll probably last for about 45 minutes, something like that. Okay. So TAs, could you come in and start working with the teams? Well, yeah. If Winchell could come, that would be great. Thank you. Okay. Well, okay, we have a topological constraint here.